Okay, hey guys, going to take off from where we left off yesterday with J3. Okay, so now we're going to look at two samples of gas, again in the containers. And if you look at them, they're moving at the same speed. You see the two marks on each container. Okay, and they're the same mass. So if they're the same speed and the same mass, which one would have the higher pressure? Well, same speed and same mass, so it would have to be neither one of them. And hopefully that is correct. All right. Ooh, now we have three samples. Okay, same number of gas particles. All right, B is moving at the highest speed. You can see the speed marks. Okay. And A and B are the same mass. C has less mass. So what would have the highest pressure? Okay. So now this is a tough one. Okay. B is moving the fastest. Okay. But A and B have the same mass, but C has the less mass. So the fastest is B, so the highest pressure is going to be B. All right. Okay, next stage. All right, the pressure of gas depends on the average kinetic energy. We talked about that again in PowerPoint, kinetic theory of matter, okay? So the average kinetic energy is directly related to the temperature. As the temperature goes up, like you're boiling water, there's more kinetic energy. Goes down, there's less. So the higher a gas's temperature, the higher the energy of the particles. So if they have the same temperature, then they have the same kinetic energy, kind of like the question before. So in the statement below about a gas in a closed rigid container, like a mason jar, click the words to correct the statement. All right, if the temperature of the gas increases, so think of water on the stove, okay? The average kinetic energy of the particles increases or decreases. Well, the temperature is going up, so it would have to increase. So if there's more kinetic energy, it's pounding on the container, so it's going to have a higher gas pressure. All right. Okay, again, we have our containers, same number of gas particles. They have the same temperature. Okay, which has the higher pressure? These appear to have a bigger mass, but these appear to have more kinetic energy, but it says they have the same temperature. Which has the higher gas pressure? They have the same temperature. Again, a tough one. What do you guys think? But I'm going with the pressures are the same. All right. Couple more. Okay. The amount of pressure depends on the total amount of force exerted on the walls of the container. So if it has more particles, the particles together can exert more force because there's more of them. Okay, so we have two samples of gas and there were containers again. They have the same temperature, but let's look at the number of particles. This one has 1, 2, 3, 4, 5, 6, 7, 8. What is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. And this one only has 6. So which one do we think has the higher pressure? Well, remember, when it has more particles, it exerts more force. So it has more pressure. So we're going to go with A. All right. Okay. Again, same container story. B has a higher temperature than A, and there are more particles in B than in A. So, which one has the higher pressure? More particles in B, higher temperature in B. So let's go with B. All right. Okay, guys, about one or two more. Imagine two samples of gas in these containers. We got an A and a B. A has higher pressure than B. Which particles exert a greater force? Okay, higher pressure. A has higher pressure than B, so we're going to go with A. What factors can contribute to the difference in force when they want us to select? Okay. The temperature. Yes, remember, the higher the temperature, the more force. And then they just told us a couple questions ago, the more particles, the greater the force. So we're going to select both of those and hope that we're correct. Woohoo! All right. So we can stop there for today. Tomorrow we will look at J4. Remember, anything over 80 and you are cool beans with me, that will be an A. All right. Take care.